Right. Good afternoon, everyone. So, welcome to your lecture number 2. In the previous lecture, we discussed the statement of Fundamental Theorem of Arithmetic, which is a very important as well as the very first result of class 10. So, today we'll start with the recapitulation of the statement of Fundamental Theorem of Arithmetic. Every natural number greater than 1 can be expressed as product of primes. Every natural number greater than 1 can be expressed as product of primes, and this factorization is unique except for the ordering of prime factors. Right? So you take any natural number. Suppose I take the natural number 135. Right? You can express this natural number, since I know that it is greater than 1. You can express this natural number as product of primes. Right? Now I know that this is what, 27 into 5. So I can write this as 3 cubed into 5. Product of primes. Right? And this factorization is unique, except for the ordering. You can write this factorization as 5 into 3 cubed. That is absolutely fine. Right? And now let me take another natural number, suppose 7. Right? 7 can also be written as product of primes. See? Product of just one prime. Right? So you take any natural number and you can express it as the product. Right? This is nothing but the fundamental theorem of arithmetic. Now we'll move on to some questions, some applications of this theorem. Right? So let's discuss the first question. Write down. First is, if 8575 is equal to 5 raised to power x minus 2 into 7 raised to power y, then find the value of x square minus y square. Right? Now what you can do is, you can pause the video, do the question and then see the solution. I will straight on move on to the solution part. Right? So I'm hoping everybody is actually paying attention. Alright. Now he says this number is written as product of 5 and 7. Some parts of 5 and 7. Right? So product of primes. Now product of primes, that means I am prime factorizing this number. Now I am sure you know how to prime factorize 8575. Right? So prime factorization actually turns out to be 5 square into 7. Right? Prime factorization. And I know since the prime factorization is unique, this would be equal to 5 raised by minus 2 into 7 raised by 5. Right? Now, on left hand side I have powers of 5. On right hand side I have powers of 5. Since these two sides are equal to one another, the powers should be same. Right? So that means this power should be equal to this. So x minus 2 should be equal to 2. Now, let's move on to the powers of 7. This power should be equal to this power. Why? So left hand side is equal to right hand side. So that means y is equal to 3. Right? You got the value of y and you know the value of x, which turns out to be 4. Right? You need the value of x square minus 5 square. Right? Just substitute it. So this is 4 square minus 3 square. That is 16 minus 9. Answer is 7. Right? Let's move on to the next one. Write down. If 52,272 can be written as p raised to power a into q raised to power b into r raised to power c, where p, q, r are primes and p is greater than q greater than r, then find the value of 4a minus 5c plus 3c. Hurry up. Right. Alright, let's discuss it on the board now. Right. I need to find the value of 4a minus 5b plus 3c. If I can find the value of a, b and c individually, I can find the answer. Right? Now, A, B and C are getting involved in this. In what? as powers of prime numbers. Why? Because P, Q are our prime. So I have written this number as product of prime. That means I need to write what? The prime factorization of this number. Again, I am leaving that up to you. The prime factorization. It turns out to be 2 raised power 4 into 3 cube into 11 square. Right? And this is equal to P raised power 8 into Q raised power B into R raised power 3. Right? Now from here, let me say that P is equal to 2, Q is equal to 3, R is equal to 11. Right? Now wait a second, let's read the question again because reading the question is very important. Now, this thing we have done, this thing we have done. This condition, P is greater than Q greater than R. That means amongst the prime numbers, P has to be the greatest one. Amongst the prime numbers, P has to be the greater one. That means from here you cannot say that P and 2 are equal. I want the greatest prime one, right? So greatest one for what? So let me rewrite this. This is nothing because P मुझे याद लेना है 11 पर into the mediocre one that for him that is Q, so 3Q into 2 raised power 4. Right? This is P raised power A into Q raised power B into R raised power C. You should have written this like this so that you do not commit an error. Now from here I can see obviously P is 11. Now I am interested in the value of A. So power is 2. Q is equal to 3, power will be equal to 3. R is equal to 2, power will be equal to 4. You know the value of A, you know the value of B, you know the value of C. Put it and you get the answer as 5. Right? Moving on. Right now, next question is 11,466 divisible by 78. Hurry up. Alright, I think sufficient time. Right, on the board now. Now, I need to establish whether this number is divisible by this number or not. Right, so basically I need to check divisibility of this number. Right, okay, now I need to study this number. Now, as I said in the first class, if you want to study the number, either you can study the number as a whole, that is also one method, you can directly divide it and see, right? Or you can study its parts. If I am talking about the parts of this number, I am talking about the prime factors, right? So, let me talk about the prime factorization of this number, which you can easily find out, and it turns out to be 2 into 3 square into 7 square into 30. Right? Now, divisibility by this number, इसकी prime factorization लिख लेते हैं. So that is 13 into 6. So that is 2 into 3 into 13. I need to check whether this number is divisible by this or not. Right? ये check करना. Let's see. If I have to divide it, so 2 is here, 2 is here. That means I can cancel these two. Right? 3 is here, 3 square is here. So that means one factor of 3 I can cancel. Okay? Good. So 1 is done. 13 is there, 13 is there, that means I can cancel these two. Now, if you realize it, if all the prime factors of this number are present over here, that means the number would be divisible by 6. So, all the prime factors of 78 are present over here, that is why this is divisible by 6. Right? So, answer is yes. Now, there might be different ways, but I am trying to bring out something, that's why I am going with this way. Right? Right on the next one is 2700 divisible by 405. I would like it if you continue with this method itself. Right. I think sufficient time. So, I need to talk about 2700 and I need to check whether this number is divisible by divisibility की बात आ रही है, so let me talk about the prime factorization of this number. Now, it's very easy to write the prime factorization because 27 into 100, 27 is 3 cube, prime factorization of 100 we already know. So, 2700 is nothing but 2 square into 3 cube into 5 square. And then 405 is only 1 into 5, so I can write 405 as 3 raised to 4 into 5. Now, I whether this number is divisible by this or not, right? So I need to check whether all the prime factors are present over here, right? So these prime factors, let me see. Now here I have 3 raised to power 4, that means 3 into 3 into 3 into 3, right? Now see whether you have 3 raised to power 4 over here. No, you have 3 raised to power 3 cube, right? You have 3 into 3 into 3. So do you think all of these prime factors are present over here? Of course not. Since you found a prime factor which is not present over here, that means the answer is no. The number is not divisible by 405. Alright? Okay. Moving on to the next one. Right now, if a number A is divisible by 34, then 3A is divisible by 51. Is this statement true? Justify. Now you just need not tell me whether it is true and false because I know you know the answer, but I need to check your justification because justification is the fun part actually. Alright, I think sufficient time on the board now. Now, if a number A is divisible by 34, then 3A is divisible by 51. I need to check whether the statement is true or false. Now, he is talking about the number A and he is talking about the divisibility, right? Since he is talking about the divisibility, let me talk about the prime factorization of A, right? So, let me prime factorize it. So, A is my number, prime factor. Now, I know this number is divisible by this. I know that. That means all the prime factors which are present over here would be present over here. Otherwise, divisible gets over, right? So, prime factors of 34. So, that is 2 and 17. That means 2 should be present over here. So, in the prime factorization, 2 would be there. 17 would be present. Right? These 2 factors have to necessarily be in the prime factorization of A. Now, there might be the case that there are some other prime numbers. Right? So, let me say into some other prime. Right? Now, he says then 3A is divisible by 51. Now, he is talking about 3A. And again, divisibility is there. So that means I will try to write the prime factorization of 3. अब 3A की prime factorization लिखते हैं. Now, तुम्हें कौन सी पता? You know the prime factorization of A. You want to go to the prime factorization of 3A. So from A you need to go to 3A. What can we do? Multiply both sides by 3. You have 3 over here, 3 over here. So here also you need 3. So 3 into 2 into 17 into some other prime. Right? You have written the prime factorization of 3A. Now he says, is this number divisible by 51? Right? Let's check it. That means I need to check whether the prime factors of 51 are present over here or not. Right? Prime factors of 51, that is 3 into 17. So 3 and 17. Check whether there is 3 in the prime factorization of 3A. Let's see. Oh, there is 3. Sure. Check whether 17 is there in the prime factorization. Let's see. Oh, 17 is also there. Since both these factors are here, that means 3A is divisible by 51. This statement is true. And this is how you will justify it. Right? Next, if a number is divisible by both 9 and 12, then it is divisible by 108. Is this statement true? Justify. Alright, sufficient time. Now he says if a number, right, I need to talk about just one number, so let me take that number to be. If a number is divisible by both 9 and 12, again divisibility is there. That means I will be talking about the prime factorization. That means I need to write the prime factorization of A. Right? Now he says the number is divisible by 9. and the number is divisible by 12. Okay, first of all, let me talk about 9. Now, the number is divisible by 9. That means the prime factors of 9 should be present in the prime factorization. Right? Prime factors of 9. That is 3 into 3. So 3 into 3 has to be present over here. Done. Now he says the number is also divisible by 12. So that means the prime factorization of prime factors of 12 would be present over here. Now, prime factors of 12, that is 2 square into 3. 2 square into 3. I have to make sure that these prime factors occur over here. So let me talk about 2 square. 2 square hai yahan pe? Nahi hai. So let me put 2 square. Right? Okay. 3 hai yahan pe? 3 is already there. You don't need to write another 3. Right? Just look at this number. Do you think this number is divisible by 9? Yes. 3 into 3 is there. You think this number is divisible by 12? Yes. 2 square into 3 is there. Right? Ab aage aur 3 ho na ho, we don't know that. Right? So that is why I will say some other prime. Now this prime might be 5, this prime might be 97, which is a prime number, right? I hope. Right? This prime can be anything. Right? So this is my tentative prime factorization of 8. Now he says, then it is divisible by 108. Is this statement true? So I need to check whether this number is divisible by 108 or not. Right? 108. The prime factorization of 108 is what? 27 into 4? 27 into 4. Yeah, 27 into 4. So let me write 27, that is 3 cube. 4, so 2 square into 3 cube. I need to check whether this number is divisible by this or not. Right? Check it. अब यहाँ पे 2 square है, यहाँ पे 2 square है, fine. यहाँ पे 3 cube है, and here I know for sure there would be 3 square. Okay, यहाँ पे 3 cube है, यहाँ पे 3 square है. Do you think in all the cases, this 3 cube would be present over here? Absolutely no. Because if I take my prime supposed to be 5. Right? Now A satisfies the condition, divisible by both 9 and 12. Right? I need to check whether this A is divisible by 108 or not. 3 cube is there, but 3 cube is not present over here. That means since this prime factor is not there, A is not divisible by 108. Right? So that means the statement is false. Right? Now whenever the statement is false, you need to give a counter example. You need to write the counter example actually. Right? Because if you want to prove a statement false, you just need one case where the statement fails. So one case means that is one counter example. So counter example हमने लिखा था. So because मैंने यहाँ पे 5 डाल दिया था. So take A to be 4 into 5 that is 20, 20 into 9 that is 180. Take A to be 180. Now I know that 180 is divisible by 9. Of course, divisible by 9. Now 180 is divisible by 12. Yes. Now, do you think 180 is divisible by 108? No. That means you found a number which does not make the statement true. In fact, it makes it false. Right? So, with the statement being false, you need to write the counter example. Otherwise, your statement or your solution would be incomplete. Alright, moving on to the next one. Write down. If 7A, no, actually write the number 7A. The number 7A is divisible by 3. Is it true that A must be divisible by 3? Must be divisible by 3. Justify. Now justification is very important, so careful. Hurry up. Right. I think sufficient time. So let's focus on the board now. Right. Now he says number 7A is divisible by 3. Now, he is talking about number 7A and divisibility is getting involved. That means I will be interested in the prime factorization of 7A. Right? So, let me write 7A. Prime factorization. Now, he says the number is divisible by 3, that means this prime factor would occur over here. That means I need to write 3 in my prime factorization. Definitely. Now, the number is 7a. That means 7 into something. Now, 7 is present on the left hand side. 7 has to be present on the right hand side. That means in the prime factorization, 7 would be there. So, into 7. Now, some other prime would be there. So, into some other prime. Right? Now, he says, is it true that a must be divisible by 3? A. He is talking about a now. That means prime factorization of a. I need to write the prime factor of a. Now, I know the prime factorization of 7a. From 7a, I need to do the prime factorization of a. Yes, 7a say a. So, what I can do is, I can make 7 disappear. I can make 7 disappear. So, can I see the prime factorization of a now? Yes. Which is nothing but 3 into some other prime. 3 into some other prime. Right? Now I need to check whether a must be divisible by 3. I need to check whether 3 is present in the prime factorization. Yes, it is present. That means a must be divisible by 3. It is true. Right? Write down the next one. The number 15a is divisible by 6. Is it true that a must be divisible by 6? Hurry up. Alright, I think sufficient time. Now he says number 15a is divisible by 6. So let me talk about the prime factorization of 15a. Why does divisibility have to be involved? Prime factorization. Now he says this number is divisible by this. That means the prime factors here would be present in the prime factorization here. So prime factors, that is 2 into 3. 2 into 3 has to be present over here. 2 into 3. Now let's look at it. The number is 15a. That means 15 into something. Right? So 3 and 5 are here. 3 and 5 have to be present over here. Now 3 is already present. I have to make sure that 5 is also present. So, into 5. And into some other prime. Some other prime. Right? Now he is talking about, is it true that a must be divisible by 6? So, he is talking about a. So, I need to write the prime factorization of a. Now, from 15a, I have to go to a. Right, 15a. So that means I'll divide by 15. So let me hide out 15. So 3 and 5 disappeared. So prime factorization of a is 2 into some other prime. 2 into some other prime. Now he says, is it true that a must be divisible by 6? Must be. Now, prime factorization of 6, that is 2 into 3. Now, 2 is present over here, 2 is present over here. Absolutely fine. 3 is present over here. Is 3 necessarily present over here in all the cases? The answer is no. In all the cases, 3 is not present over here. That means the statement is false. Now, whenever the statement is false, you have to give what? A counter example. Counter example सोचे A सोचना है. So यहाँ पे मैं डाल देती हूँ 5, 7, anything you like. I'll take even the basic one, right? So I'll take my A to be 10. And my 15a would be 150. Right? So let me check. 15a is divisible by 6. We check whether 150 is divisible by 6. Yes, it is. Is divisible by 6. But a, which is 10, is not divisible by 6. Right? That is why this statement is false. Right? Moving on. Write down. Find the number of 3's in the prime factorization of the number 7 into 8 into 9 into so on into 42 into 43. Find the number of 3's in this. Correctly, please do not commit an error. It's an easy question, but you need to do it correctly. Alright, sufficient time. Now he says find the number of 3's in the prime factorization of this number. Now one way is you can find out this number. Just multiply 7, 8, 9, so on till 42, 43. Then write the prime factorization. You can find how many 3's are there. A little bit cumbersome method, right? I will not do that. Now, he's talking about the prime factorization of this number. Now, 3 is saying prime factorization of 3. Factors of 3. Where will it come? Obviously, factor of 3 will not be present over in 8. Right? It will not be present in 11. Factors of 3 would be present in multiples of 3. I think multiples of 3, I can write it down. So 9 is a multiple, then 12, then 15, then 18, then 21, 24, 27, 30, 33, 36, 39, and 42. Right? From only these numbers, I'll get my 3's, right? So let me see how many 3's I'm getting from 9. Now careful, 9 has 2 3's, 3 square, right? So I'll get 2 3's. From here, 1. From here, 1. From here, 2. Careful. From here, 1. From here, 1. From here, 3. Careful. Right? From here, 1. From here, 1. From here, 2. Careful. And this, 1. And this, 1. Right? Just calculate it and you'll get the answer as 17. Right? On to the next one. Find the number of zeros. The number of zeros at the end of the product. At the end of the product. Product is 16 into 17 into 18 into 19 into so on into 103 into 104. Find the number of zeros at the end. Right? Now, number of zeros at the end. So if I take my number to be 230, number is there at the zero is there at the end. If I take my number to be 3700, zeros are there. Then 49,000, zeros are there. Now, if I want to calculate how many zeros are there at the end, I need to check how many tens are there. Right? Because this is 23 into 10, this is 37 into 100, this is 49 into 1000. So basically the powers of 10. I need to talk about the number 10. Now, obviously, I will not talk about 10 as a whole. I will talk about its parts. Right? That means I will talk about the prime factors, which is 2 and 5. Right? If I want to make 10, I have to make sure that 2 must be present and 5 must be present. That means they should be present as pairs. Both of them will be there, then only I get my 10. So I care about 2, I care about 5 collectively, right, as a pair. So let's see. Now the thing is, one way is I can write how many 2's are there, right? So maybe from 4 I'm getting, from 16 I'm getting 4 2's and stuff. I can write how many 2's are there here, how many 5's are there here, and then I can say how many pairs become, right? Now wait a second. 2's भी चाहिए, 5's भी चाहिए. Up to 16 से आएगा, 18 से 20, 22. In fact, every alternate number would give you 2, right? Factor of 2 because every alternate number is even. Now, there would be abundance of factors of 2. Factors of 5 on the other hand, it will be every fifth number. The factors of 5 would be less. Now the thing is, factors of 5 would be less, right? Mr. Pairing बनानी. अगर ये कम है, तो pairs भी कम हो जाएंगे. I care about these number of 5. Because 2 तो मैंने रहे. In order to make the pair, I have lots of 2. I can do that. I care about the number of 5 because they are less in number. So instead of calculating number of 2's, I am calculating number of 5's. Why would I do that? I just need number of 5's. I'll calculate that. I do not care about 2 because I know 2 is there. I've taken it for granted. right? So what I'll do is I will find the number of 5. So factors of 5. Factors of 5. Okay. So let me just write. Obviously, factor of 5 would not be present in 18. It would be present in the multiples of 5. Let me write it. Right. So I think it will start with 20. Then 25, then 30, then 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. That's it. Yeah, 105 hoga nahi? Done. Right. From here, I'm getting just 1. Here, I'm getting 2 factors of 5. So careful, 2. Then 1 again. Then 1 again. Then 1 again. Then 1 again. Then 2. Careful. Right. Then 1 again. Then 1 again. Then 1 again. Then 1 again. Then 2 again. Careful again. Then 1. Then 1. Then 1. Then 1. Careful. 2 again. Right? You can add them up and the answer will turn out to be 21. That means there will be 21 zeros at the end of this product. 21 zeros. Alright? Okay. Write on the next one. Find the number of zeros at the end of the product. Now the product is 15 raised power n into 74, where n is any natural number. Come on, hurry up. I think sufficient time. Now, number of zeros at the end of the product. That means I will be looking for the factors of 10. Right? That means I'll be looking for the pairs of 2 and 5. If I can find how many number of pairs are there, I can find how many zeros will be there. Right? Okay. So 2 and 5 के pairs बना दिया. Now, my number is 15 raised to n into 74. This is my number. And here n is any natural number. So, n can be 1, it can be 2, it can be 3 and so on. That means this thing is 15 into 15 into 15 and so on into 74. And I need to see how many pairs of 2 and 5 are there. Now, as you can see, I can get 5 from here. Factor of 5. Obviously, factor of 2 I will not get. Factor of 5, blah, blah, blah. Right? Now, the only number which has factor of 2, that is 74. I will only get 2 from here. And I will only get 1, 2. So, यहाँ से मिला और तो मुझे 5 मिल रहे बहुत सारे. I'm getting a lot of 5, but I'm not getting 2. Right? So that means since 1, 2 is there, I can pick out any 5 from here and I will get just one pair of 2 and 5 because there was just 1, 2. So that means how many zeros? Since just one pair is there, that means just one factor of 10 is there, that means there will be 1 0 at the end, which will be answer. Right? Next, find all solutions of the equation x square minus y square is equal to 93 in natural numbers. In natural numbers. Hurry up. I think sufficient time. Now, he says find all solutions of this equation in natural numbers. Now, I will say, ma'am, we do not know how to solve a quadratic equation on 2 variables. Fine. But he says you need to find solutions in natural numbers. First of all, solution. The meaning of solution is I need to find the corresponding value of x and y, which will make left hand side equal to right hand side. I am interested in the value of x. I am interested in the value of y. Simultaneously. But he says the solution should be in natural numbers. That means the x and y that you are trying to find out, they are natural numbers. X and y are natural numbers. Okay, fine. I understand this point. Now, look at the equation. This is a very nice equation. X square minus y square is equal to 93. X square minus y square. The first thing that comes to my mind. It's an identity, class science. Right? I can write this as x plus y into x minus y. This is equal to 93. I need to solve this. But I know that x and y are natural numbers. X and y are natural numbers. Now, this is a natural number, this is a natural number. Two natural numbers I'm adding. What will I get in this case? A natural number. Okay. Now, I'm subtracting two natural numbers. Mind it, right hand side is positive, so negative nahi aayega, right? This also will I get natural number. So, natural number into natural number should turn out to be equal to 93. That means I have expressed 93 as product of two natural numbers. 93 as product of two natural numbers. Really? Really? I think I can find out easily. 93 as product. I can say 93 into 1. 93 is a natural number. 1 is a natural number. Then I can say it is divisible by 3, right? So 31 into 3. Right? This is 31. This is 3. Now I can reverse it also. This is 3 and this is 31. Then 1 into 93. That's it. These are the four cases that you have exhausted. You can write 93 as 93 into 1, 31 into 3, 3 into 31 and 1 into 93. Here ordering matters because you are saying that x plus y is this, x minus y is this, corresponding. Right? These are the four cases. Just take the case one by one. So first case, let me take. First is this, second is this, third and fourth. The first case is x plus y is 93 and x minus y is 1. And I am interested in the value of x and y. Now, x and y, I need the value of x and y. So somehow just one variable would have been there, I could have found the value. Now here I have plus y, here I have minus y. If I add the two equations, these two will get cancelled out. So adding the two equations, I'll get x plus x, that is 2x. This gets cancelled out, this is 94. Right? So x will turn out to be 47. You have found the value of x. Just substitute the value of x in any of the equation. Maybe you can put it here. So 47 minus y equal to 1. So y turns out to be 46. Right? So this is one such equation solution. X equal to 47, y is equal to 46, satisfy the equation. Check it. Done. So first we have used it. Second, in the second case, x plus y is 31. X plus y is 31 and x minus y is 3. X minus y is 3. Again, you need to find the value of x and y. So plus y minus y. Adding the two equations, I will get 2x equal to 34. So x equal to 17. Just substitute this value over here and you will get y as 14. This is another solution. X equal to 17, y is equal to 14 is the solution of this equation. Right? Now the third case. Now in the third case, I can write it here. X plus y is 3 and x minus y is equal to 31. Now wait a second. Sum of two natural numbers is 3 and their difference is 31. You think that is possible? Of course not. I will not even check it. Right? Done. So this case is rejected. Next case, x plus y is 1, x minus y is 93. Again, sum of two numbers is 1 and the difference of two natural numbers is 93. I should have said sum of two natural numbers 1, difference of two natural numbers 93. Do you think you will find such natural numbers? Of course not. Right? This is also rejected. So that means these are the only two cases where you will find these solutions. So first solution, x equal to 47, y is equal to 46. First solution. Second solution, x equal to 17 and y is equal to 14. These are all the solutions of this equation over the collection of natural numbers. Right? With this, we are at the end of lecture 2. Home assignment 2 would be uploaded and I think it's already been uploaded. So you should definitely attempt it. Thank you and I will see you.